Hello, everybody. Welcome to this talk. I live in Mells near Frome, so this is probably my local tech conference, which is awesome. So it's great to be here. Before I start talking about Kubernetes and Jenkins X and all that kind of stuff, I just want to talk about this book. How many people have read the Accelerate book this year? Oh, you're good. Okay, how many people have heard of the State of DevOps reports that have been out every year for like about 4 years, 5 years? So I highly recommend it. It's coming up for Christmas. I highly recommend this book. Put it on your Christmas list, like nudge everybody you know, get people in your office to buy this. This is one of the most impressive books I've read in a very long time. It's awesome. It's one of those books that you kind of read and like half of it you go, yeah, I knew that. But because it says it in the book, you know it's right. And then the other half you're like, oh my God, is that true? And it's just awesome. But basically this book is based on the State of DevOps reports, which has been going for about kind of 5 years. And every year they kind of hone the science and the surveys to figure out basically what makes high-performing teams, right? So what is it that high-performing teams are doing that makes them much, much faster than low-performing teams, right? And every year they figure out different things to ask and figure out more and more nuggets of awesome information. So please buy this book, it's totally amazing. I'll just give you a few of the little facts that every time I think about them blow my mind. So this year's report, 2018 report, found that high-performing teams are up to 2,600 times faster than low-performing teams at delivering value to production, right? So just think about that for a second, right? You could do 1 day's work and be 4 years ahead of a competitor with 1 day, right? Like 1 day. So that's pretty amazing. Like I remember, do you remember all the, is there such a thing as a 10x developer? And ooh, is one developer 10 times faster? This is 2,600 times. And this is not made up. This is all based on, scientific survey. So 2,600 times faster, that's quite a scary number, right? Another one I really, really like, using the cloud well you tend to be 27 times more productive if you're a team that uses the cloud well versus other teams. So there's all these metrics in there. Dive into all of them they're described in detail in the book, but they're all totally mind-blowing. But the basic idea is we can all become high-performing teams and we can all go faster, but by going faster, that doesn't mean we, chucking code over the wall and all the code's kind of crappy. It also means we can make more reliable code. So by going faster, it's kind of counterintuitive. But by releasing all the time and going quickly, we can release more high-performing, more well-tested, more bug-free code. So the time to recovery is faster, the bug defect rate is quicker, the mean time to recovery reduces, and so forth. So high-performing teams is a place we all should be at least trying to get to. Now, one of the really good things in the book is it kind of says anybody can be a high-performing team, right? It doesn't matter which industry you're in. It doesn't matter if you make printer drivers that are burned into hardware. It doesn't matter if you're in healthcare or finance or telco or you're online retailer. It literally doesn't matter. They've done lots of surveys to figure out, does it matter which industry you're in? And it doesn't. Any team can be a high-performing team in any industry. It doesn't mean you've just got to hire rock stars and all this kind of stuff. It's more about what you do and how you do it, rather than, what languages do you know, or have you written a programming language by yourself or whatever. So it's all about really any team can be a high-performing team, which is really empowering. Now, I'll let you read the book for all the gory details, but just a few of the things that the book says, oh, sorry, too many slides, is some of these things you probably already do, like using version control. Like I hope most of us in the room use version control, but using version control for versioning all of your artifacts, right? Some people still use like snapshots everywhere and deploy to production. Whatever the snapshot is, I'm just going to run that in production. That's really scary. That's not good, right? So always version everything and use explicit versions so you know if suddenly something breaks, you know which was the exact version that broke so you can go back to a different version. So always use versions of everything. Automate your deployment process, right? Some people go so slowly, they deploy once a year and they think, well, I'm just going to like SSH in and I'm going to tile some stuff up and I'm going to manually release, right? Automate your release procedure. Trunk-based development, that's slightly more contentious. A lot of people really love their long-term feature branches, right? This is quite a thing, and this is not me saying it, right? This is the book. This is not me. The book found that long-term feature branches is not a high-performing team trait. High-performing teams use trunk-based development. In other words, merge to master all the time. The basic idea is if you've got, say, 3 long-term feature branches, you're in kind of merge hell all the time. And what tends to happen is one person works for, say, a month and changes a ton of code and then commits. And then the other 2 people are like, damn you, I've got to now merge for the next 4 weeks. And I could break anything while I'm doing it, and you have no idea, and it's just horrendous. And so you get into kind of merge wars where, oh my God, that guy merged. I hate that guy because he merged before me, and now I've got loads of crappy work to do. So trunk-based development is a nice tip to avoid that kind of crap by doing lots of little small incremental changes and merging to master all the time. Okay, so trunk-based development, it's not me saying it, but I highly recommend trunk-based development. It's a good thing. Continuous integration, I guess we all do continuous integration, right? Does everybody do continuous integration? Okay, maybe not many people do. Okay, let's do more continuous integration. What is continuous integration? It's about checking that all your code changes still work, right? So checking whenever you make a change in Git or whatever source control you're using, run your tests and check, have you broken anything, right? Check that everything's kind of working all the time. Another kind of best practice is keep your release branch or master branch clean at all times. And another way of doing that is by using, for example, pull requests. So rather than just pushing to master any old random change, which could break anything, submit a pull request and then run your continuous integration on the pull request to go, does that still pass all the tests? If it doesn't pass the tests, reject the change and so it doesn't merge. So you keep master clean at all times so you're ready to release, right? What tends to happen is you often, once you go to production, you often have like important bug fixes that need to go out. And you also have long-term, let's hack this feature over here in the corner kind of changes. If you hack some long-term feature and merge to master and break master, you can't get any production bug fixes in, right? And you get into this hell and then you start using long-term feature branches and then everything becomes really slow. So by keeping changes small and keeping master clean, you can go much, much faster, right? What we all really need to focus on is how do we deliver software value to our customers quickly? Because if we don't do it, someone else is going to do it faster and our business is going to be out of business fairly soon, right? We're going to be Ubered or Airbnb'd or whatever by some young, snappy startup. So we all need to figure this stuff out, right? But it's not rocket science. It's just following best practices that is now known in the industry. Implement continuous delivery. How many people do continuous delivery right now? Okay, how many people want to do continuous delivery right now? Yes! Well played, you picked the right room. Okay, I'll show you how to do that in a minute. Implement loose coupled architecture, yeah, empower teams and blah, blah, blah. So what we've tried to do on the Jenkins X project is we've tried to go through all of the Accelerate book. And so some of it's about culture and how teams operate and how you organize teams and a little bit like microservices and all that kind of stuff. So some of the book you can't really automate with software, but a lot of the things you can automate with software. And what we've tried to do with Jenkins X is automate what we can do in the Accelerate book to make it so that you can all go quickly without having to figure all this stuff out for yourself, right? Which I'll show you in a minute. So, firstly, oh yeah, I should talk about the cloud. Before I show you that slide, one of the findings was, I mentioned the stat, I think, people who use the cloud well is a high-performing team factor. Anybody who uses the cloud well, what does it mean to use the cloud well? Okay, so some people use the cloud. They've got like 3 machines under their desk, and then they go, yeah, we should move this to the cloud. So then they make 3 VMs, and then they copy the code from these 3 machines into the cloud, and they say, hey, I'm using the cloud because I've got 3 VMs on EC2. Okay, that's not using the cloud well, right? Using the cloud well is everything's elastic, everything's multi-zone, everything's multi-region. You're letting the cloud provider deal with high availability and fault tolerance and scaling so that things are always running. Those 3 VMs you spun up could die, right? At any point in time. Using the cloud well is letting the cloud provider manage your stuff so you can just focus on other important things like being an SRE or whatever, right? So using the cloud well is an important trait. Now, when the cloud first came along, we all just spent our lives making VMs and pooping them up to Amazon and using EC2, right? Which is okay. But what's kind of cooler is using containers. Why are containers cool? They're smaller and faster. So they take less resources and memory and disk. And so they're cheaper to run, right? On average, a container is around 20% cheaper than a VM to run. So basically, if you're using lots of stuff in the cloud, you get 20% free on your hardware bill, which is pretty good. Once you start running lots of stuff in the cloud, it kind of gets expensive. So we all should be using containers. How do you run lots and lots of containers well across any cloud infrastructure? This is where this thing called Kubernetes comes in. Now, we all used to talk about Docker all the time a few years ago. Docker was the thing that everybody talks about. Now everybody talks about Kubernetes all the time, and Docker's kind of more of an implementation detail. Basically, all Kubernetes is a thing that runs containers at scale. Think of it as like a mini Google infrastructure that you can run in any data center, right? You can run it on your laptop, you can run it on those 3 machines under your desk, you could run it on your official company internal data center, or you could run it on Amazon, Google, or Azure, or DigitalOcean, or any of the commercial clouds. So IBM, Oracle, Red Hat, Pivotal, pretty much anybody who's even Docker, anybody in software now supports Kubernetes as a way of running software. And all Kubernetes really does is runs containers for you on a bunch of boxes. And if your container dies, it starts another one for you. If a box dies, it starts all the stuff that was running on that box on other boxes. And it orchestrates containers, which basically just means it packs containers onto hardware and makes sure they keep running, right? Which is kind of cool. So you can take any Kubernetes cluster and say, please run my app, please. I need 3 Tomcats. And it will go, OK, and it will run 3 Tomcats. And if one of the Tomcats fail, it will run another Tomcat. And if you want, you can do elastic load balancing that says, run as many Tomcats as I think I need. And based on the HTTP traffic, it will scale up and down the number of Tomcats, and it will load balance across them all. So all that common stuff that we have to do on every single system, scaling, being elastic, scaling up and down, and all that kind of malarkey, it just takes care of all that kind of stuff for you. So you can focus on writing your application, packaging a Docker image, and releasing it, right? So it's really simple. Here's a little diagram of what Kubernetes looks like. You don't really need to know or care about any of this stuff, but it's just there if it helps. Basically, Kubernetes is a bunch of nodes, machines, which have a little daemon on them called a kubelet, and that basically controls which containers run on which box. And there's this API server thingy where you say, please run 3 Tomcats to, and it looks at all the nodes to see what's running everywhere and has this little feedback loop that goes, you asked for 3, you've got 4, I'm going to kill 1. You asked for 3, you've got 1, I'm going to run 2 more now. And it just constantly keeps looking at what you asked for and what there is and scales up or down based on what's happening, right? So if a node goes away, it goes, oh, we just lost 2 nodes. What was on there? I've now got 1, let me run 2 more. So it's constantly automating running your software at scale, which is kind of what Google have done for like a decade. Now we can all do it. We can all be Google-ish, right, on any data center, which is cool. Increasingly, it seems like, so the last 5 years, it feels like more's happened in IT than has happened in decades, quite frankly. Yeah, the internet was quite big, but now all this kind of cloud and container and Kubernetes and stuff is kind of quite insane, really. But it's one thing that's really kind of empowering is, okay, step back a bit. There was a time 20 years ago where I thought maybe there's going to be like one programming language. Like maybe we're all going to agree that, say, Java, is the programming language, and everything's going to be Java. But actually, it's kind of gone like that. Every year, there's another programming language for another reason, for another platform, for another use case. And there's more and more programming languages all the time. There's more and more frameworks. There's a JavaScript framework every day. There's different libraries and tools all the time. There's machine learning, big data, all kinds of, there's a gazillion databases out there. Everything is fragmenting. For the one time only I can remember, we've now decided there's one way of running software on any cloud or on any machine, right? There's one way of packaging your application and deploying and running it on any infrastructure, right? Which is Kubernetes, which is truly amazing. And we're not talking about, 12-factor, trivial, stateless, crappy little things. We're talking about, Cassandra or MongoDB or React or ActiveMQ or anything that's stateful, sharded, clustered, highly available, like real complex enterprise applications. You can package them up and run them on any Kubernetes cluster, right? Which is truly, I'm still kind of shocked it happened. For a while, I thought it wasn't going to happen, to be honest, because I thought nothing this awesome can happen. But now is really the most exciting time to be a developer, because now you can write an application once and deploy it literally anywhere, right? The cloud used to be, here's a massive, complicated, proprietary Amazon API for everything, and here's OpenStack, which is a thing, and then that was the cloud, and it was a nightmare, and nobody quite knew what to do and what to pick, and should we emulate Amazon on everywhere else, and should it be whatever, what should it be? Now there's just Kubernetes, and we can just go forwards and make apps and deploy them everywhere. Increasingly now, most companies are now saying, we need a public cloud strategy. That might be a hybrid one, because some stuff might have to be on-premise or whatever, so we need a on-premise, hybrid, public cloud strategy. Even a lot of, for example, most investment banks are going all in on public cloud. Even those folks are saying we need a multi-cloud strategy. So we need to deploy on, say, 2 clouds at least, probably 3. So we can't go all in on proprietary Amazon APIs. We need a way of defining an app once and running it on any cloud, which is really Kubernetes, right? So this is a beautiful time to be alive. It's awesome. So I highly recommend you look at Kubernetes. It's a beautiful, wonderful thing. But as I'll hopefully show you, you don't really need to know much Kubernetes to use it really well. And I'll show you that in a few moments. So Kubernetes is awesome. Use the cloud well. Automate your CI and CD. So if you learn nothing else from this talk, those are the things. Use the cloud well, automate your CI and CD, trunk-based development, if you can convince people on your team to go that way, and use Kubernetes. So let me talk about Jenkins X. So Jenkins without the X, so Jenkins no X, has been around for like 15 years. It's been doing CI for years and years and years. How many people use Jenkins already? Most companies have got a Jenkins somewhere. Yeah, that's good. Thank you. So Jenkins was written in a very different age, right? When a single JVM was like a cloud, a different kind of thing. What we've done with Jenkins X is we've tried to reimagine what Jenkins even means in a cloud world, and we've tried to. So we love Jenkins, right? Don't get me wrong. Jenkins, like when you start Jenkins, there's the 1,500 plugins. You can do all kinds of crazy stuff in it and useful stuff in it. So it's a massive box of Lego bricks that you can do literally anything with it. What we're trying to do with Jenkins X is more the opposite way. You come along with your source code and we kind of take it from there and do CI and CD for you. If you really care, you can look behind the curtain and see what it's doing, but you shouldn't really need to worry about that stuff. So rather than becoming a Jenkins Jedi master to figure out all these different plugins and syntaxes and Jenkins files and stuff, we want to just automate CI and CD for you so you can focus on building your app and let Jenkins X just take care of it for you. So that's the kind of the big picture. Oh, I pressed too many keys. So how does Jenkins X help? So firstly, it automates the setup of all of your tools. So to do CI and CD well on the cloud and on Kubernetes, you need lots of different bits of software. One of the things that's awesome about the Kubernetes open source ecosystem is there's a gazillion things happening and people are reimagining and reinventing all kinds of different things all the time, which is awesome. It's not quite JavaScript crazy, but there's lots of stuff going on, right? And it's quite hard to keep track of what are all these tools, which tools should I use this, should I use that? So for example, Helm is something you might have heard of. Helm is a package manager for Kubernetes. Think of it like any package manager you like. It could be NPM, it could be Yum, it could be Maven, possibly. Those kind of package managers that install versions of things for you. So Helm is a way of packaging up an app, versioning it, making a tarball out of it, and make it so anybody can take that app and install it anywhere. And then most importantly, they can upgrade it or downgrade it once you've installed it. So it's really, really useful, this Helm. Scaffold is something from Google. Don't worry about these tools, I'm just mentioning them. You can forget about them when you use Jenkins X. Scaffold is a tool from Google that helps. Making Docker images is actually quite tricky on a Kubernetes cluster. There's all kinds of different ways of doing it. Scaffold kind of hides all that stuff from you. So you can just get Scaffold to build your Docker image and you don't need to worry about things like Docker sockets versus something called Canico and Google Container Builder and all sorts of other stuff. Nexus, I won't bother talking about Monocular is just a repository to browse Helm charts. So basically, Jenkins X, one of the things Jenkins X does is it automates setting up all the tools you need. Another thing Jenkins X does, which is probably more important than just setting all the tools up, is it automates setting up your CI and CD pipelines so that you're ready to do development and to do releases on Kubernetes across multiple environments. So that's really the meat of what Jenkins X focuses on. So you literally can just bring along some source code and say, hey, here's my Java, here's my Node, here's my whatever, and it will set up all the CI and CD for you. And you don't need to really worry about it, and you can just use your app and go faster. One of the things Jenkins X does is it uses something called GitOps, which is a new trendy buzzword that the we folks invented, I think this year, maybe last year. GitOps just means, well, in essence, we all should be using source control to manage our source code. Let's use source control to manage each of our environments. Okay, so imagine you have a development environment, staging environment, and production environment, say. Most people I've ever talked to in the last couple of decades have in their head the idea of environments. Right, I've got some code running here, we'll run it in a test environment or a staging environment, maybe a pre-prod. We call them all different names. You might call it UAT, pre-prod, production, whatever. So you move code from one place to another, to another, to another as it gets closer and closer to your real users, right? So you might run stuff in the staging environment for a little while, check it's all okay. When you're happy with it, you'll promote it to production, right? Now, to manage those environments, one way you could do is you could just manually configure each environment completely independently, right? You could just have a machine, you could just copy with tar, all kinds of random files on there and just boot it up and go, woohoo, I've got an environment. That's one way of doing it, but what's kind of cooler is if you automate it so that you have a repeatable, automated way of moving some code from development to test to staging to production. And this is the idea behind GitOps. Let's use a Git repository for staging. Let's use a Git repository for production. And then let's be able to diff them. Like, how does staging differ to production at any point in time? And then move versions of software through environments by just changing version numbers in source code, right? So let's use source code as a way of configuring infrastructure. If ever you've used things like Ansible, that's kind of how Ansible works. You check everything into Git, and you have source code of your Ansible playbooks. GitOps is kind of like that, but for kind of containers and Kubernetes and stuff. I'll show you an example of all that working in a minute, but GitOps is basically the idea of let's use source control for environments as well as the actual source code that builds apps and builds Docker images and things. Lots of feedback. So as we start doing CI and CD, we need more and more feedback. There's another strand to all of this. In the aim to go faster, microservices are now very popular. So in the old days, we'd all work on one massive monolith, and we'd release it a couple of months a year. We'd release this big, huge thing, and it would take weeks and weeks of testing before one release goes out. And the bigger it got, the more mass it had, and the more momentum it took, and it took more and more people to push this thing over the wall. Now, to fix the monolith problem, we've realized, well, why don't we just do microservices? Split this big monolith into lots of pieces, release them independently. That's the big trick. Release the microservices independently, so then little teams can work on one microservice and can go really, really fast. And then you don't have these big, huge coordinated releases across 100 people. So once you start moving to microservices, we're now doing gazillions of releases all the time. So we need more and more feedback so that different teams can understand what's happening in different releases of different microservices across a large, complex organization. So this is generally what we're trying to do with Jenkins X. Let me show you quickly how to install it, and then I'll show you a live demo, and then we can dive into more and more detail. So the first thing with Jenkins X is you need to install it somewhere. So there's a binary called JX for Jenkins X. So there's a little binary. There's a binary for Windows, Linux, and a Mac. You can compile it yourself for other kind of crazy platforms, but at least for those three, there's a binary that you can just download. So you download the JX binary, pop it in your path somewhere, and you're good to go. Then the next thing, you've got two options. You either create a brand new Kubernetes cluster and install Jenkins X on top of it, which is the JX create cluster. Or if someone's already made you a Kubernetes cluster, you can do JX install. Now, we prefer you to do the JX create cluster. We support right now Google with GKE, Amazon with COPS or EKS, Azure with AKS. I can't remember the acronyms anymore. IBM Cloud is IKS, I think. I can't remember. But basically, IBM Cloud, Oracle Cloud. Pivotal is PKS. So this word GKE, you can switch that from the cloud of your choosing. So we support most public clouds and a lot of on-premise clouds. We don't support spinning up a new cluster of things like OpenShift, for example, because there's no CLI to spin up a cluster of OpenShift. So you have to spin up a cluster of, say, OpenShift first, and then run JX install. But we should be able to install Jenkins X on pretty much any Kubernetes cluster. If you find a cluster that doesn't work, just let us know, and we'll fix it. It's been tested on most Kubernetes clusters. If you have to pick somewhere to run Jenkins X, my tip is GKE on Google. It's the simplest, easiest way of running Kubernetes today on the public cloud. And Google announced this year GKE on-premise, so you can use the exact same UI and CLI to create and manage clusters on your own premise and in the public cloud and have a hybrid, so some workloads on-premise, some workloads on public cloud. It's all using the same software, it all looks and feels the same, and it's all managed in the same way with logging and alerting and management and stuff like that. So GKE is looking really, really awesome. If you're an Amazon shop, then EKS is looking pretty good. If you're an Azure shop, AKS is looking pretty good, and all of the managed Kubernetes offerings are getting better and better all the time. A quick point on installing Kubernetes yourself. So friends don't let friends install Kubernetes. It's not a, you can install Kubernetes really quickly. You can type kubeadm install and it kind of gets going with one node. What managed Kubernetes offerings are giving you though is something different than just installing something on a box, right? As soon as you do this JX create cluster GKE or EKS or AKS, you're getting a managed cluster of Kubernetes that is guaranteed to be up all the time, and the cloud provider is monitoring that and spinning up nodes all the time. So for example, with Google, you could lose a data center and your cluster will still run and it will just move the cluster to another data center, right? So the managed offerings are amazing. They install Kubernetes for you, they upgrade it, they fix CVEs in Kubernetes for you. There's a little, sorry, I'm creaking on the floor. You can upgrade and downgrade your Kubernetes versions with the UI. You just say upgrade version and it upgrades your cluster for you. You can scale up and down really easily. So it might be you spin up a cluster and then you say, well, just before I go home, I'm going to scale it right down because we're not really working on it much. And then when I come in the morning, I'll scale it back up because I'm just developing on it or whatever. So the managed offerings are really, really awesome. If you have to work on premise, then sure, look at installing it yourself. Talk to CloudBees or talk to Heptio or somebody like that, and we can help you get going installing it locally. But I think longer term, my recommendation would be GKE or Azure on-premise. It's such a awesome, simple service because it looks and feels the same as the public cloud. And then you can have a mixed workload of some stuff public, some stuff private, and it all just kind of works together, right? It might be that you do all of your development in the public cloud and then you run production on-premise or vice versa. You run production on the public cloud and develop on-premise. Well, that would be silly, but if you wanted to do it, you could do it that way. So basically, look at the public cloud. It's the easiest, fastest way of getting stuff done. Installing and managing Kubernetes yourself is a lot of hard work, and it's undifferentiated heavy lifting, right? Just outsource that to somebody like one of the big three and get cracking and focusing on your application, because that's really, where you should be working. Another thing worth mentioning, on the public cloud, Kubernetes is basically free, right? On GKE, you're not charged for Kubernetes, you're just charged for the compute nodes that runs your workloads. So you can spin up a cluster and have 0 nodes on that cluster and you don't get charged a penny, and you're only charged for the nodes that run your workloads. So Kubernetes is effectively free on the public cloud, you just pay for compute and disk and network and stuff. Anyways, end of lecture, but please use the public cloud if you can, it's awesome. So use one of these two, use create cluster or use install JX install. The create cluster creates a new Kubernetes cluster for you and then installs Jenkins X on top. This one just installs Jenkins X on whatever cluster you're connected to, right? Either one of those two commands is basically one command of you've now got Jenkins X set up. So what does that give me? Oh, here's a very quick video. Don't worry too much about the detail. Oh, it didn't work anyways. I could show you it if you like. This is a very quick video, if the Wi-Fi is working, of how to install on GKE. So you might be able to see at the top, JX create cluster GKE. It asks you a few things like which zones and how many machines do you want to use and whatever. If you're doing this for the first time, just keep hitting return until something cool happens, because you don't really need to change anything. And basically that sets up a new Kubernetes cluster. It sets up something called ingress so that you could use a web browser to look inside the cluster for exposed services. Then it sets up a couple of Git repositories, which I'll talk about in a minute. And then you're ready to go. So it's pretty much about 2 minutes on Google. It's about 20 minutes on Amazon, but that's hopefully coming down a bit soon. So within, let's say, an hour, you should be able to have Jenkins X working on any one of your preferred clouds, and then you can get going. So what does that give you? Once you've done all that kind of JX create cluster stuff, what do you get? So each team gets their own development environment where the tools run. So by default, each team gets their own Jenkins master where your pipelines will run for CI and CD. You get an elastic pool of build pods. So if ever you've shared like a Jenkins between like lots of departments, you have like a gazillion jobs in there, and you trigger a job and you see this queue that says, I've only got 500 jobs, and then you'll get a chance to have your stuff built. With Jenkins X, every build is triggered immediately, assuming you have enough compute node in your Kubernetes cluster. So there's no queue. Every job is immediately triggered in Kubernetes and just builds, which is kind of cool. You get your own Nexus and your own monocular. If you want to share a Nexus, you can point at a Nexus or SonarQube, Nexus or Artifactory that's outside of Kubernetes, or you can share a Nexus between teams or whatever. But the nice thing is all of these tools just work together out of the box, right? You don't have to open up Jenkins and tweak it, and open up Nexus and tweak it, and mess with your Maven this and Maven that. Everything just works together out of the box. It's all cool. Also, every team gets their own staging environment and production environment, and this is important. So one of the whole ideas of becoming a high-performing team and going quickly is each team should be allowed to release any microservice they wish to their staging and their production. You shouldn't have to ask permission, please, can my team release something? The idea of microservices and going quickly is each team is empowered to release and manage their own code whenever they want. So there's no like central authority you need to get a permission on. As we'll see later, you can enforce approval if you really, really need it, but the general idea is we should empower teams to go quickly and not have to keep asking for machines and VMs and stuff like that. Okay. So yeah, we're good. I might speed up ever so slightly. Right, once you've got Jenkins X installed, what do you do next? How do you like create projects and install software and get stuff usefully done? So if you've already got some source code, there's a command called JX import, which if you like cd into a directory that has some source code, you can just type JX import and it will take your source code. If it's not already in a Git repository, it will create a Git repository, set up the webhooks, set up the pipelines, and boom, you're good to go. If you're creating a brand new microservice from scratch, there's something called JX create quick start, which will give you a whole bunch of different microservice quick starts in Angular, React, Node, Go, Java, Gradle, Spring, all kinds of random stuff. And you can pick the one that suits your workload, and then boom, you've got a microservice that builds, deploys, and runs, and then you can just tweak it to add your custom business logic. If you're a Spring Boot person, which a lot of people are Java these days, and Spring Boot seems to be the most popular way of doing Java these days in microservices, JX create Spring. So it's basically one command, you've got a new project, and everything's kind of cool. Right, so let me do a live demo on the conference Wi-Fi on the public cloud. What could possibly go wrong? So this totally worked 5 minutes ago. I've got a backup video if it all goes pear-shaped, but I'll try to do a live demo. So I've installed Jenkins X on a Google Container Engine cluster. I've got a 3-node cluster. If I do JX get env, or for JX get environments, let's see if the Wi-Fi is working, cool. You can see I've got a bunch of different environments, and you see there's a Git repository there. I'll talk about those Git repositories later. So I'm going to create a brand new microservice. I'll stick with, how many people do Java? Do quite a few Java folks? Yeah, okay. I'll stick with Java to start with, but we can do more demos later. I'll create a Spring Boot application. So JX create Spring. Now it's going to ask me which programming language should we use. Now obviously Groovy is the best programming language. Well, I'll go Java because that's probably more popular. And we'll pick a cool name, Bristol Rocks. I should say, this is the Spring Boot initializer, or start.spring.io thingy, where you can spin up a new Spring application. This is the Spring Boot dependencies, which is nothing Jenkins X specific. So I'm going to pick web and actuator as the dependencies in my microservice. So now it's going to create some source code. Which Git user do I want to use? I'll use my own. Commit message, create a Git repository, please. So now it's detected it's Maven, so it's made a Maven build pack. I'll talk about that in a minute. Now it's going to upload this code to GitHub, hopefully, if GitHub's working today. Let's give it a minute. Phew. And if the internet's working and GitHub's up and Google Cloud is all up, this is all just going to totally work. Whoa, it's looking good. Yay, yay. Okay, so I've just created a brand new GitHub repository. Let me just show you that. Let me type this command in first. I can watch the activity of all the pipelines that are running in my cluster. I'll do that in a minute, actually. If I click on this URL, let me show you the Git repository that I've just created. So this is a project you can see 30 seconds ago. I've just created this brand new Git repository. You can have a look at the repo online if you want on your phone. It basically just contains, it's just off the side a bit. Let me move my window ever so slightly. It's just a vanilla Spring Boot application. It's the same Spring Boot application you get if you went to start.spring.io. One of the slight differences, though, apart from just vanilla Spring, is you might notice there's a couple of other files in here. So there's a Docker file, which is the file that packages up the Spring Boot executable jar as a Docker image, so you can then deploy it on any container infrastructure. There's also a Jenkins file there, which is a thing that implements the CI and CD pipelines. And there's also a charts folder, which is where the Helm charts are defined. If I just go back to my terminal, I'm just going to type this in. This is a little handy command. Oh, sorry, I started typing stuff. What this does is it displays to my local terminal all the activity in the pipeline for my application. So we can see that in the background, because I've created a brand new application, it's created a Git repository. It's wired up the webhooks so that whenever we make a change in that Git repository, it triggers CI and CD pipelines. And it's already triggered, you can see a release pipeline, because whenever we merge to master, we make a new release. So whenever we do a merge to master, we make a brand new version, and then we release a new version. So we can see the pipeline chugging along there. While that pipeline's chugging along, let me just show you a little bit about what's happening. If I type, by the way, right now, by default, there's a Jenkins master for each team. We do support pluggable execution engines. So if you don't want to pay the cost of running a Jenkins master for each team, we do serverless Jenkins as well, which basically means there's no Jenkins master. And it just runs a build pod every time it needs to run a build. But I've used a Jenkins master for now because most people are familiar with Jenkins. So if I type Jenkins console, JX console, sorry, it opens the Jenkins console. So this is the console, this is the Jenkins server that's created for me automatically for each team in Jenkins X. Take a little while to load. I might go to the classic console. It sometimes takes a while to load, does the blue ocean thingy. I'll give it 2 more seconds. No, too slow. Okay. This is the classic view, the traditional Jenkins UI that you've probably seen before. So we'll see inside my username, I'll make it ever so slightly bigger. We'll see Bristol Rocks has been created. So we've created a new Jenkins pipeline for Bristol Rocks. You'll see because we pushed to the master branch, there's a pipeline running on the master branch, and we can see we've checked out source control, we've done a CI build, we've built the release, and now we're promoting to the environments. If I show you my terminal, there we go. We'll notice it says we've done version 001, and we've got a pull request. If I'm quick, let me show you, well actually let me show you the pull request first. If I look on the releases tab, notice we've got a release 001 and we've generated some release notes. So every time you push to master, we generate a new version number. We use git tags to figure out the version number. So if you want to go from 001 to 002, just push to master. If you want to go from 002 to 100, just create a git tag 100. The next one will be 101, 102. Or you can change the POM XML or change the package.json if you want, whichever you want to do. So we generate a new version number. We tag the git, so you can see we've tagged git for that version number. We generate the release notes. We use this conventional commits thing that if you use conventional commits messages, we'll group all of your commits by new features first, then fixes, new features, fixes, docs, chores, something like that. So we'll generate nice release notes, basically. So we generate nice release notes. We've also generated, we've created a POM XML and a jar of the Spring Boot application and published that to Nexus. So there's a 001 version of this jar that anybody could use from Nexus. We've also created a Docker image with 001 as the label. We've generated a Helm chart with 001 as a label, so anybody can consume what we've just released via Maven, via Docker, or via Helm, which is nice. And then we're promoting, I'll best be quick now to show you this bit. We've generated a pull request. Now this is the pull request we've just generated. Now notice we generated this pull request. Oh, it's already finished. I was too slow. So it generates a pull request, and then because we generated a pull request, this pull request is in a different Git repository. So if I just look at the top of this screen, see that there? This Git repository is for my staging environment. So I have a Git repository that all that Git repository does is store all the versions of all the apps that run in my staging environment. So to promote a new app into staging, what Jenkins X does is it generates a pull request on the staging Git repository. Let me show you what that pull request looks like. And this pull request basically says, please add this new application called Bristol Rocks. That's the repository where it lives, and version 001. Now, we do this to promote to staging. We do this to promote to production. You can create as many environments as you wish in any team. So you might want a SOAK testing environment, a load testing environment, a security vulnerability testing environment. You might have a canary environment. You might have a blue-green environment. So one environment's blue, one's green. You can promote from anything to anywhere whenever you want using the command line. We have a commercial UI for it. There's an IDE plugin for it. Or you can just edit Git directly with a pull request. But what it means is anybody can look at the source code of any environment and see exactly what's there and who's wanting to make a change and why. And then you can use things like you might have commercial or legal requirements that whenever you make a change in production, you need 3 people to +1 it, or you need a ServiceNow ticket or a Jira or a whatever it is. Your boss needs to sign off on a change or whatever the thing is. You can assign all those workflow human-y things to pull requests, right? For me, the most important thing of GitOps is production's working fine, all of a sudden production fails, and you go, ooh. Now, if you're not using GitOps, somebody has gone in there with SSH and done something to production, and you have no clue who did what where. With GitOps, every change goes through Git, so you can see production's down. Let me look at Git. Oh, James promoted that new version. Maybe that's the problem. Let me just Git revert. So it gives you a really simple way of reverting changes and at least seeing, as a team, who changed what, when. Let me look at the diff. Let me just revert it. So GitOps is a really, really powerful, simple way of managing environments across your organization, where you can do rolling upgrades upwards or downwards of versions or change environment-specific configurations, right? Really, really nice. So what we did, let me just step back, because that was quite a lot to take in. I typed one command, create Spring. I've created a new Spring microservice. I've set up CI and CD for it. It's created a new release, and it's promoted it to staging. And this last URL shows the URL where it's running. And if I click on that, if the demo goes, yay, it's working. This might not look like it's working. That is actually a Hello World Spring Boot app. That's exactly what it looks like. Honestly, that's it really working. I know it looks like it's failing. That's the working Spring Boot app. And I'll show you how to change that to look like something different in a moment. So basically, you type one command and you've gone to staging. By default, we say we'll automatically promote to staging, and then it's up to you to manually choose when to go to production. Now, we want you to go automatic straight to production, but we know that a lot of people, it takes them a little while to trust automatic promotion to production. You might want to add certain automated tests or whatever to make you happy that it's ready to go to production. You might want to leave it in staging for a week or a day or something, and then go to production. So how you trigger the production promotion is up to you. We've left it, staging is automatic, production is manual, but you can change this however you want and have as many environments as you wish. So one command, we've got CI/CD, we've gone straight to production. So every time we merge to the master branch, we're now going to create a new release, a new version, a new Docker image, a new jar, a new Helm chart, and promote it by default to staging. Now let me show you how pull requests work and how I do a change. So I'm going to cd into Bristol Rocks. So here's my source code that I just created. I'm going to copy a magic file from my home directory, if I can remember where it lives. Yeah, desktop fixes to the source folder. Before I start, I'm going to go into a Git branch because we should not push to master. That's kind of naughty. So I'm going to do a git checkout -b changes. So I'm in a branch. That's cool. If I do a git, I'll do everything on the command line so you can see there's no like ninja, there's no magic. Everything I'm about to do is just vanilla git, right? There's no Jenkins X specific stuff here. I've added a file, so I'm going to do a git add source main, there, git status. I've added a file, I think. So I've added a HTML file. That's all I've really done. So I'm going to do a git commit, -a -mem, fix homepage. So I've done the commit, and I'm going to do a git push, normal git. Everything's working so far, yay. And then I'm going to type a magic command, jx create pull request. Now you can actually just go to GitHub and do the pull request by hand, but I'm just going to automate that. There's a pull request title based on the last commit. That all looks good to me. So I'm going to create a pull request. This is just a regular pull request. I could do this through the Git UI. I could do this through your IDE. It really doesn't matter. So I've created a pull request. So let me look at the pull request. So here's the pull request on GitHub. So I've proposed a change. It's just a normal diff, and you can see in that diff, I've just added a page. I've added a HTML page that shows Jenkins X and shows a little icon. And if I go back onto this other, if I rerun that one, we should see, you see this pipeline started called PR1. A PR1 pipeline has started. So what's basically happened is we set up CI and CD. So that any Git repository, if you create a pull request, it spins up a pull request pipeline. And what that pull request pipeline does is continuous integration. Right? It validates, does your stuff still work? Did you break anything? Does it still compile? Do your tests pass? Have you done anything really bad and whatever, right? So it's a bit like doing, if you're a Maven person, Maven test, right? And if we look at the GitHub page, we'll see, you can see it's gone like orangey color because a CI job is running, and you're not going to be able to, or you shouldn't be allowed to merge this branch. We haven't turned on branch protection yet by default, but you shouldn't be able to merge this until the CI job goes green, right? You really shouldn't. We should automate that, to be honest, but anyways, yeah. So there's a CI job running to check this is all valid, which is good. So we're getting CI for free and CD for free, which is great. One other thing we do as well, which is kind of cool, by default, we also make something called a preview environment. Now, imagine you're working on a web UI, right? You're working on a web UI, and somebody makes a pull request, and they've changed a HTML layout and some CSS. Now, when you're doing code reviews with your team, which is a good practice to do, it's not mandatory, but it's a good practice, you might want to look at that diff and go, they've changed some CSS. I have no clue if that looks good or bad. I really don't know. And mentally rendering CSS is pretty hard to do. Not many people can do that in the head, right? So what we do is we do the normal CI stuff, and we check, does it do all the tests pass? Is everything good? Then what we do is we create a preview environment in Kubernetes. Kubernetes has a thing called namespaces, which means you can just spin up a logical namespace and just deploy some code, which is isolated from all the other namespaces. So it's like a way of virtually sharding a Kubernetes cluster into logical units. So we can spin up, so for example, staging is one namespace, production is another namespace, development's another namespace. So what we do with preview environments is we spin up a preview environment just for this pull request, we deploy a preview Docker image and Helm chart of that pull request into the preview environment, and then we comment on the pull request to say, everything's green, and here's where the code's running, and here's a URL of where the live code is running in Kubernetes, right? Now, I don't know if you've ever had this, it works on my laptop comment before, right? You're going to go, I've checked this pull request, I've totally checked it totally works on my laptop, and then you try it on your laptop, and it doesn't work at all, right? Even if it did work on your laptop and it works on their laptop, does it work in Kubernetes? Who knows, right? With the preview environment, we check every pull request works in Kubernetes. If it doesn't work in Kubernetes, the pull request fails, you can't merge. It's very easy to break a pull request so it doesn't actually work, right, in Kubernetes. How am I doing for time, by the way?
4 minutes.
Oh, crap. Okay, I'll go quicker. So if I just hit reload. Oh no, there's no pull request comment. Oh, damn. Oh, that's a shame. But there's the pull request, I think. Oh, yeah. Okay, maybe the pull request demo is not working. This totally worked a minute ago. Okay, so there should be a comment. The comment's not there. There's normally a comment that shows you where the pull request is running. And then any minute now that pull request is going to be running here. There we go. So there's the pull request running. There should be a comment on the pull request though. I'm really gutted it's not there. I'm quite cross. So normally there's a comment on the pull request with that URL. So right now that's the URL of the pull request that's running in Kubernetes. And if you look really closely at the URL, you'll see the pull request, the repo and the pull request number is in the URL. So each pull request gets its own URL. So if ever you do a pull request and then you change another commit and do another push, you can just hit reload to try the new version of the code. So you can review the code and then choose when to merge it. Okay, so that was a very quick recap. With Jenkins X, we automate CI and CD so that you can immediately go straight to staging or production and then do pull requests from there, validate your pull requests, use preview environments, and check all the time everything's running in Kubernetes. So that's basically it, right? Use Jenkins X, it's awesome, and go faster. And I've just got like 2 minutes for questions. And any questions on anything I've done so far on Kubernetes?
There's a microphone just behind you.
I'll leave a few URLs on the page while we do questions.
So are you, within this, are you doing anything to declare, so say for like monorepo,
Yes.
are you doing anything to like put declarative dependencies between applications so that you can work out which applications rely on other applications? Because if you're doing CDC type testing, then you need to check it works against other things, right?
Yes.
Are there any plans to that?
That's a great question. I'm going to firstly sidestep the monorepo question first and just talk about modular applications. So imagine you've got loads of libraries, and then so you've got, say, a couple of libraries, and those libraries are used by 10 microservices. We have a little a tool called UpdateBot. And UpdateBot is a thing that as you do a release, it generates pull requests on all of your downstream dependencies, your downstream projects that use user dependency. And we use this ourselves. So whenever we release a library, as part of the release, we do CD for libraries. And so CD for libraries is, you don't necessarily deploy a library to Kubernetes, but to deploy a library to a project, you add it to a POM XML or a package JSON or a Docker file or a Helm file or something like that. So a library is deployed using source code, but it's not deployed as a Docker image. So this UpdateBot thing is is our version of deploying a library, right? Monorepos, though, we don't have any. The build packs we have right now are based on microservice-ish projects. So either a Git repo is libraries, it's NPM modules, it's one or more Helm charts in a thing. If you go the true monorepo route, where you have a massive tree with a gazillion libraries and microservices and Helm charts and Docker, we have no automation for you for that right now. So our automation is focused on traditional microservice approaches. So either a Git repo makes a bunch of libraries, or a Git repo makes a composite Helm chart, basically. But yeah, great question. So UpdateBot is the quick answer. Yes. And any other questions? Go for it.
Hi, thanks for the talk. Is it limited to just GitHub, or?
That's a great question. I should have made that a bit more clear. We've started with GitHub and GitHub Enterprise. We have plugins for Bitbucket Server, Bitbucket Cloud, GitLab, and Gitea. They're not all completely at the same awesomeness. So there's a few kind of bugs here and there, particularly with Bitbucket right now. and GitLab. But we're working hard on making them as awesome as each other. Definitely GitHub Enterprise and GitHub is awesome, and we use it all the time. And we're working to nail those last few bugs in Bitbucket Cloud and Server and GitLab. But we're aiming to support all the popular Git providers, is the aim. And they're almost there. They're just not quite as awesome. Any more questions? Oh, sorry, whoever, I can't see the back. Yes, you at the back first. Yeah, go for it. Then you're next. Yeah.
I saw there's some really cool features coming with cloud native Jenkins as well.
Yes.
Are these two things tied very closely together, or are they going to be available separately? Because I kind of get the impression this isn't for like classic Java like products, let's say.
That's a great question, and if I'd had a bit more time, I would have shown you this slide. One of the aims of Jenkins X is to automate your CI/CD for Kubernetes, but it's also to help make Jenkins more cloudish and cloud ready. And one of the ideas, so totally if you just want CI/CD for Jenkins, for Kubernetes, use Jenkins X. But also if you want to operate Jenkins in a more cloud native way, look at Jenkins X. Jenkins X is essentially an orchestrator of Jenkins. So one of the first things is we have something called serverless Jenkins. So you can choose to use serverless Jenkins, which basically means you don't have to run a Jenkins master. Now, Jenkins masters take up a reasonable amount of disk and CPU, right? They're not exactly small. They're like 2 to 4 gigabytes. They sit there all the time, not doing very much for most of their lives. So serverless Jenkins allows you to not run that at all and just spin up a JVM for each pipeline and then it disappears again. We're also working on using GitOps to manage large estates of Jenkins servers. I work for CloudBees, lots of our customers have a lot of Jenkins servers. So we're using Jenkins X as a tool to help automate managing any Jenkins, right? So if you've already got Jenkins in your organization, we're using Jenkins X as a tool to orchestrate many Jenkins across many teams, which might all have different configs and plugins and all that kind of stuff. But definitely serverless Jenkins is one of the core pieces of Jenkins X right now. There's also another movement in the Jenkins ecosystem called cloud native Jenkins, which is a confusing term. It kind of means cloud storage for Jenkins, but it also means using Jenkins X for non-Kubernetes workloads. So for example, if you're releasing NPM modules and tarballs and Node stuff and Maven, and maybe even AMIs, you could use classic workloads or classic workloads in Jenkins X without the Kubernetes stuff. So we have pluggable workload plugins in Jenkins X. So if you don't want to do Kubernetes and you just want to do Maven deploy, for want of a better phrase, we have pluggable workloads in there. This is all slightly confusing, and I'm hoping we can explain this in a less confusing manner. But the basic idea is Jenkins X is increasingly becoming the cloud-native incarnation of Jenkins. Whether that's orchestrating lots and lots of Jenkins servers, whether that's serverless Jenkins, whether that's automating lots of workloads of different kinds. I hope we can have a Cloud Foundry build pack soon. I hope we can have Heroku. I hope we can have mobile and so forth. So we're going in all those different directions in parallel. So it's slightly confusing. Sorry, that was a very rambly long answer. But good question.
Thank you.
One more question?
Thanks for the talk. On the surface,
Yes.
Jenkins X and GitLab's Auto DevOps seem to have a very similar offering.
Yes.
Why should I pick Jenkins X over that?
Because it's more awesome. Because it's not a monolithic Rails app. No, I'm not good. No. So what we've tried to do with Jenkins X is build from the ground up all the best of breed open source pieces so that you can use any of those pieces together. From 30,000 feet, GitLab is doing something similar. So I guess just try them both out, see which one you prefer. From 30,000 feet, they're similar. One's written in Ruby and one's written in Go. One's like that. They're similar but different. Yes, similar but different. Definitely Jenkins X is way more microservice-y and less monolithy. But yeah, try them both out. Conceptually, for 37 view, they're similar, yes. But obviously, Jenkins X is more awesome. Any other questions? I think we're almost out of time. I'm here for the rest of the evening, by the way. Come and grab me if you have any questions about any of this. Any more questions before we finish? Okay, thank you very much. Enjoy the rest of the day.